This is the brief on the geometric and mechanical analysis of the magnetic field tensor. Okay, so what's this all about? Well, it really dives into the elegant math that connects how we define a magnetic field using the magnetic field tensor to the actual physical forces it exerts on stuff, which is described by the Maxwell Stress Tensor. First, you've got to handle a key mathematical requirement right up front. You have to prove that the product of the field tensor with itself has a special property called symmetry. This step is absolutely crucial. Think of it as a sanity check that makes sure the entire force calculation is stable and physically realistic. Second, once that symmetry is confirmed, we can see what that tensor product is really made of. It breaks down into two parts: a uniform, isotropic energy term that pushes out equally in all directions, and a highly directional term that acts specifically along the field lines. And this is the real breakthrough, because it lets us formally define the force tensor using the field tensor. And finally, we get to the physical interpretation of all this. The whole structure confirms that magnetic fields create a net tension, a sort of pulling force that's always positive and runs along the field lines. And at the same time, it creates a net pressure, a squeezing force that acts perpendicular to them. So the magnetic field tensor is the powerful mathematical tool that perfectly models the tension and pressure forces fields exert on matter.